Assalamualaikum warahmatullahi taala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to question number 3 on impulse response, where you are given this linear differential equation and you are asked to determine what is the impulse response of the system. So the first step, in order to solve this problem is to rewrite this linear differential equation in terms of the operator d. So over here we have d square plus 6d plus 9 equals to 2d plus 9 x of t. Okay, so the next step is to determine BO and PD. So BO here is the multiplier for d to the power of m. However, we have to first check what is m and what is n. Okay, so over here, this is m, which is equals to 1. And n is the highest power, okay, to the d in y of t. Oh, I forgot to write here y of t. Okay, so this one is n. We have n equals to 2. So in this case, we have m, which is 1, smaller than n, which is 2. Therefore, we have BO equals to 0. Now, PD is simply the polynomial over here. This is PD. While the polynomial over here, the polynomial for the output is known as QD. Okay. Therefore, PD is equals to 2D plus 9. Now we have to determine lambda and C in order to determine Yn of t. Now lambda is the roots of the characteristic equation Q of lambda equals to 0, where we obtain by substituting d in QD with lambda. So our QD is d square plus 6d plus 9. So we will have lambda square plus 6 lambda plus 9 equals to 0. If we find the roots, this will be lambda plus 3 square. Okay, so actually we have a real and repeated roots. Okay, lambda 1 equals to minus 3, lambda 2 equals to minus 3, which simply means lambda equals to minus 3. Okay, two real but repeated roots. Which means the general solution to Yn of t is equals to C1e minus lambda t plus tc2e lambda t. Sorry, this is no minus. Okay, so this is e lambda t. So if we substitute lambda, we will get n of t equals to C1e minus 3t plus tc2e minus 3t. Right? Since we have two unknown, okay, C1 and C2, so we need two equations. So let's differentiate this Yn of t in order to get Yn dot of t. So it will be minus 3 C1e minus 3t minus 3 C2t e minus 3t plus C2e minus 3t. So we can find now what is C1 and C2 by utilizing initial condition. And we know, okay, from the theory that when we have n equals to 2, dyno is 0 and dyn dot 0 equals to 1. So we have two initial conditions. So we can solve yn of t. Let me just use a different color. So yn of 0 equals to, so simply substitute this t with 0 and this t with 0. This is 0 equals to c1 plus t, sorry, this t is 0, c2. So the whole thing will be 0. So 0 equals to c1. Okay. Now yn dot of t equals to equals to 1, and you substitute this t with 0, this t with 0, and this t with 0. So you are left with minus 3 c1. For this one, the whole thing will be 0. So you are left with plus c2. Okay, and we know that c1 is also 0, so you will have c2 equals to 1. Okay, so now we can substitute c1 and c2 back into our equation. So we have yn of t equals to, c1 is 0, so we are left with t, c2 is 1, e minus 3t, while the yn dot of t is equals to, c1 here is 0, so we're left with minus 3 t e minus 3t plus e minus 3t. Then the next step is to determine h of t using this equation. Okay, so we can substitute because we have everything. And remember, BO is 0. So we will have h of t equals to PD yn of t ut, which is PD we obtain from step number 2 equals to 2d plus 9 ynt ut. So if I multiply, I will get 2d yn of t plus 9 yn of t ut. Now this part here simply means first derivative of yn of t. So I have 2 yn dot of t plus 9 yn of t. So here what you have to do is simply substitute this yn dot t and yn of t with this value here. Okay, if you do that, you will get h of t at the end. Okay, you substitute and then you perform all the operation. You will get h of t equals to 3t plus 2 e minus 3t ut. Okay, that's all for this video. I'll see you in the next one. Thank you.